All right, lesson 9-2, part 2. We are going to continue this problem and talk about the domain and range. So the domain, as always, should be listed as all real numbers, but the range is dependent upon how the problem works. This one we already said, because it is concave up or facing up, it has a min point. That's the vertex at -2, -1. So that means the range would be all of the y's such that y is greater than or equal to -1. That's how you determine the range. When it's a min going up, it's going to be greater than or equal to the y value at that vertex point, greater than or equal to -1. The next example talks about something that looks a little more difficult. It says, if an integral root cannot be found. What that means is if it doesn't cross the x-axis on integers and it's between numbers, that's a problem. You need to estimate the root to the nearest tenth. So you find between what two integers it falls and then make a table of values using increments of 1/10 for the x values. That sounds horrible, and it is. I'm not going to lie. You're going to use your calculator when you get to that point. But you start off just like we did everything else, like normal. X squared minus 4x plus 2 equals 0. We're going to go ahead and write our a, b, and c. What's a?
1.
What's b?
-4.
And c?
2.
Okay, and we're going to look at our vertex. X equals -b over 2a. So -4 is what?
4.
4 over 2 times 1. So 4 over 2, 2. So my axis of symmetry is at 2. And that's where I would have it graphed in there. Next we go on to the vertex. We have half of the vertex already done. Which half? The x is 2. You plug that into this equation. So 2 squared minus 4 times 2 plus 2. So 2 squared, 4 minus 8 plus 2. What is it? No, 4 and 2 is 6, -2. So 2, -2. That's my vertex. Is my parabola going to go up or is it going to go down? Up, because A is positive. A is positive. It's going to go up. What is my y-intercept? Cole? 2. So it's going to cross the y-axis at 2. And we're going to go ahead and get our freebie. So 2 units to the left is up at 2. So that means we're going to go 2 units to the right up at 2. If we follow the lead of what I talked about last example, my axis at +2, we know what it is where x is 0. What's the obvious choice to try? 1, because that's between the two. So we're going to try x at 1. X at 1. I didn't put the y-intercept down, but I graphed it. All right, so x at 1, we're going to use that equation. So we're going to say 1 squared minus 4 times 1 plus 2. 1 minus 4 plus 2, what is that? Let's see if we can get it. -1. So 1 is at -1. What's my freebie?
-1, 1.
So 1 unit to the left of this, +3, -1. 1 unit to the left of the axis of symmetry is at -1, so 1 unit right is at -1. Now here's the problem with this. as I'm graphing this, and I try to be as careful as I can, it's definitely not going to hit on an integer, is it?
No.
So it's somewhere on this side between 0 and 1 that it crosses. See, it crosses right there. And over here, it crosses between what?
2 and 1.
No. 1, 2, 3, and 4.
Oh.
It crosses between 3 and 4. So what you need to do at this point, this is the part that's not so pretty. You need to do increments, decimal places, to figure out where it crosses. So you would actually go ahead and put 0.1, 0.2, until you get where it gets closest to 0. So we're going to stop the video. I'm going to break the class into 2 halves. Half of you are going to try one side, half of you are going to try the other. We're going to come back on the video when you have your answers. All right, so now what's going to happen is I've assigned you values to try so that we can do the estimation. All right, so I have assigned all of you a 10th. We know that it crosses somewhere on this side, we said between 0 and 1. On this side between 3 and 4. And so I took the class and assigned everybody a different 10th value between those integers. You have to plug them in here, and then I'll explain how you figure out your answer. So we've kind of narrowed it down, and we're going to come over to the side over here. Caleb, can you tell me the 10th value that I assigned you?
0.5.
So I gave Caleb 0.5, and he took 0.5, plugged it into x squared minus 4x plus 2, and when he did that, he got what value, Caleb?
0.25.
0.25. So that is very close to 0. So we're going to have to see how it goes from there. We're going to go next to Skylar. Skylar, what did I assign you?
You gave me 0.6.
0.6. And when I gave you 0.6, what did it come out to be? Negative 0.04. So as you can see, it fell below the x-axis. So it crossed in between these two values. So to estimate, like they're saying up here, to estimate to the nearest tenth, you decide, is negative 0.04 closer to 0 or 0.25 closer to 0? And I think everybody would agree this would be the closest. So your first estimate would be 0.6. All right, now on the other side, so Adam, what x value did I give you?
0.4.
3.4, right? 3.4. And when you plugged in 3.4, what did you get for the y value?
Negative 0.04.
Negative 0.04. Does that look familiar?
Yes.
Look at that. It matches the other one, doesn't it? We'll go ahead and say, Mackenzie, what did I give you? 3.5. And is 3.5, I'm guessing, 0.25? Aren't they symmetrical? Check this out. See how they're symmetrical? And we agreed that negative 0.04 is closest, so it's 3.4. Let me ask you something. Could we have decided after we knew it was 0.6 over here what the other one was on the other side?
Probably.
Yes, because it ends up being symmetrical on both sides. So if you find out how far in one direction, it's the same distance on the other direction. So it's 1.4. Like my axis of symmetry here at 2, if I know it's 3.4, it's 1.4 units right. So we would know to go back 1.4 units. That would make it 0.6. Either way, my two solutions that we estimated would be then 0.6 and 3.4. That is estimating the roots when you can't find them on an integer.